Now that we have a complete model of a robot in CAD, it's time to start working towards being able to manufacture it. In this case, we will only be manufacturing a single piece, the base plate, because the rest of the parts come in the kit already. To manufacture parts, we convert the CAD models into drawings. Drawings are a way of communicating all the critical dimensions that are in the CAD to the fabricators so that they can make the parts. Here's what our drawing will look like when we finished it. As you can see, it has all the dimensions for the locations and the sizes of the holes and the other features on our part that we'll be making. Let's get started. Switch to your base plate part model, and then click the arrow next to the New File button in the toolbar. Then click Make Drawing from Part/Assembly. It'll ask you what size paper you want to use. Select A size portrait, that's the same as 8.5 by 11, and click OK. On the right side, you will see that it has various views that we can put into the drawing to be able to start marking up. In our case, all we need is just the top view, so drag that out into the drawing. It will then allow you to make additional views if you would like to, but in our case, just the top-down view will be sufficient. So hit Escape to stop doing that. As you see, it's defaulted to a very small scale drawing relative to the size of our 8.5 by 11 sheet of paper. So to scale it up, click on the view. Then in the bar on the left here, scroll down to Under Scale, click Custom Scale, and then select 1:1. Now it's time to start adding some dimensions to our drawing. On the Annotations tab of the toolbar, click Smart Dimension. We add dimensions into our drawing the same way we do in sketches, by clicking on two features that we want to put a dimension between. So let's take this hole. So if I click on the hole, and then click on one of the edges of the parts, it will allow me to place a dimension about the distance between them. Since most of the features on this part are symmetric about the center line, we will create a center line and make most of our dimensions from that. So if you click the center line button on the toolbar, then click the leftmost line and the rightmost line, and it will add a center line in the middle as you see here. Click the OK check mark to get out of center line mode, and then if you click on the center line, you'll be able to grab one of the handles at the end to extend it to be full height. Now we can go back to Smart Dimension and add a dimension between the hole and the center line. For the hole on the opposite side, we could dimension it to be a certain distance away from the center line as well. But when we make this part, the critical dimension, the dimension that we want to make sure is accurate, is actually the distance between these two holes. So we'll make that dimension instead. We have the other two holes down here. And in order to be able to, that are the same size and part of the same set of four holes, to express that to our fabricators, we can go to the Sketch tab and make a new rectangle that connects all four of them. This helps express that there is a dimensioned connection between these 4 points, and means that we don't have to specify every single dimension in the set here. Because we've specified this distance to be a 1/2 inch over here, we don't need to specify it again on this side. What we do need to specify is the distance between the top set of holes and the bottom set of holes. So we can go ahead and add that in now. For these set of 4 holes in the middle here, we will also dimension them relative to the center line. And as the distance between the symmetric sets of holes. If you have trouble selecting parts, a good strategy is to zoom in further, which allows you to more accurately click on what you want. We also mustn't forget to specify the holes of the size of the holes themselves. To do that, just click on the hole, and it will allow you to call out the size of the hole. This symbol of the circle with line through it means the diameter of the hole. So the diameter of the hole is 0.18 inches, for instance. In this case, to make it clear that we're talking about the diameter of all 4 holes in this set, we can, on the left, edit the dimension text to have a 4x in front to specify that this size is for all 4 holes. Similarly, when we add a diameter dimension to these holes, we can add the 4x there as well, to specify that all 4 of those holes in the center of the part should be the same dimension. Now we can do the holes at the bottom of the part. And similarly, we can use the rectangle to specify the connection between all 4. Add some smart dimensions to give the locations of the holes. If it prompts you about making a dimension driven, just accept the make this dimension driven option and click OK. This is saying that the position of the holes is already specified by the part, and so the dimension that you're putting out there is just indicating what's already present instead of adding a new dimension, which is exactly what we want in this case. Now we can also specify the dimensions for the perimeter of our part. For specifying the height, what we want to do is specify the distance from the very top to the very bottom, because that will give the amount of material that we need to cut out. As you can see though in this case, because the bottom surface is curved here, we can't accurately give a dimension between that. It ends up dimensioning something else entirely. So to get that dimension, a good strategy is to place another rectangle from a corner here, and then if we just place this corner out there, then we can add a couple of additional constraints to pull this in to be the exact size of the part. You click the bottom line of the rectangle, then holding Shift, click on the curved segment. We can apply a tangent relation to pull that up there nicely. Similarly, on the right side here, if we use the Shift key to select both the end of the edge of the rectangle and this edge of the part, we can use a collinear constraint to make that representative of the size of the part. Now that we have this rectangle in place, we can use a smart dimension to give the height of the entire part. You can add in the last couple of dimensions here, specify the width of this cutout, and just to be safe, we can specify it on this side as well, though it is the same on both sides. And then the last dimension that I forgot earlier is the offset between this set of holes and the edge of the part. There we are. Now to print out your part, connect your computer up to the printer, and then you can use the usual file print method in order to print it out. You should double check under page setup that portrait orientation is selected so that it matches the orientation of the page that you've just made up. Unfortunately, this isn't selected automatically, so you have to double check to make sure it's the same across both. Once you've ensured that, click OK, and your part will print.